two. One is the IIB toolkit and the other is IIB runtime environment. That is they provide in a console, that's command based console, that we can use it to handle the integration servers, integration nodes. So this is the two main thing in IIB 10. Actually, it's segregated from the dependency on the MQ, message queuing. So that is also IBM product. IBM MQ was integrated with IIB before in IIB until IIB 9 version. So in the 10th version, they segregated it and made it separate. So whenever we don't want any protocols like MQ protocols, queue-based communication, if you don't want, so that time we will use only IIB with IIB toolkit and IIB servers only. No need of taking a license, separate license for the MQ. So then what happens if you want MQ, so queue-based communication, most of the projects want. So that time you have to take a license for the MQ, and in the MQ you have to build a queue manager, queues and all. So all those things you have to build it. So after building it, you have to connect from IIB to MQ. So there are different ways we can connect it. So there is a remote queue manager. So then the local, if it's hosted in the same IIB, then local queue manager, it happens. Then there is a policy file, through that we can connect. So this way, there are many ways we can connect it to the queue manager. So these are the main artifacts of IIB. Now again, there is one more. It is in earlier versions, like until 8, we have a dependency on DB2 also, database. They are internally storing some system data to the database. Now that also they removed, and now they are storing it in file-based command files. Or if you are using queues, you can shift it to queues. So there are in the administration, it comes like how we can manage file-based security or queue-based security. Sometimes you can switch it to the IIB. So this way, this MQ and DB2 are become optional now. So and there are different ways we can connect to the database, and that we'll cover later. And the basic things you have to learn first is like how the toolkit works and what the use. A toolkit is for the developers who want to develop the flows, workflows. Then once you develop the workflows in the toolkit, they have to deploy it in the runtime environment. That runtime environment is provided by integration nodes. So this is the concept where runtime environment works. How integration node works is as a collection of multiple processes. Look, it is further divided into integration servers. So integration servers are multiple. It can be one or more integration servers under the integration nodes. So integration servers, it works as a separate operating system process, one single process. So if you check here, this is integration nodes. Under this is the integration node name. So I'll go inside this. So it takes me to some 4 integration servers. So common, default, IS1, IS2. These are the 4 integration servers it is hosting. So what are the use of integration servers now? Integration node having multiple integration servers. So we can have multiple address space here, and when you deploy something like application, it's an independent process now, threads. So here common, if you are having make any of integration server, you can create it here. So like integration server name is common. So here we want to deploy only common codes. So here default method like finance things, and here anything related to billing, other things we want to deploy that kind of flow. So it's sometimes we need to segregate the flows. We should not interact with other things. So that's why we have different integration servers. So all these integration servers runs on the JVM, Java Virtual Machine internally. So it creates its own thread. For each message flow, it creates one thread. So that thread will run when the message, it gets the message into the message flow. So it will continues. And also each message flow, we can make multiple instances. So we want to handle more data. So same message flow can handle multiple things, multiple requests at a time. Then what happens? Then we have to make instances more and deploy. Suppose you created 20 instances of the same message flow and deployed. There is an option to configure in the message flow that thing. Then we deploy it, and what happens? The 20 threads will get added to that. Then at a time it can handle 20 requests. So each integration server, now for the same message flow, it can have more threads. So it can have performance will be better. No need to wait for the other requests. It will 2020 it will handle like that. So this is the main thing about the runtime environment in the IIB. So, and how the IIB does application development. So in that application develop, to do that, it provides some packages here. One is application and integration server and libraries, and under that we can create message flow, message models, everything. That once you have a package, like it comes before it was having only message flow project. In that project we have to add message flows and all. Now in the from the version 8 they come up with application package like this way. This is A. We can see the icon as A. It will show as A as application. So same as if yes means integration service. Integration service is mainly for SOAP web services. So whenever doing a development, we can make use of integration service. So then there is a library called, this is the library symbol. So whenever you want anything to be shared between multiple applications, so you can make that as a library. So you can use that library in a multiple times for the different applications. So no need to create each and every time the same thing. So whatever the common things are there, you can put it into the library. So in the library also there are different kinds, that is shared library and the static library. In the static library, what happens once you create a library, that becomes, when once you create a library, static library, then include it in the application. Then that application includes that library in on their application. Once you deploy it, it will part of that application. So what happens, that whole copy of the library get deployed with the application. Now it's part of the application. So in the shared library, what happens, if you reference that library to the application, so once you deploy the application, it will not get deployed, because it tells the dependency on the shared library, because it can't be part of single application. When you include that, it's only referring to that library. So for that reason, we have to deploy that library, the shared library, into the integration server. Then you deploy the application to the same integration server. Then it refers, that library refers that integration library in the same shared library in the same integration server. So again, the one more application, like second one, A2 application, you are referring the same shared library, and you can deploy the library again, the application A2 again in the same integration server. Then it deploys properly, because there is already a shared library which also referred by this application. It's already there. So this is the difference. We'll go through that, how it works and all. So let me give a brief idea once the whole idea how it integration development happens. So this is about application and library, and then there is a message modeling. So we have different kinds of messages, like XML is the common thing, SOAP messages, and JSON, any COBOL messages for the mainframe, even the industry standards, HL7 for healthcare, Swift for the finance or banks, Edifact for logistics, Arts for the retail. So these are the different message formats available. So based on our need or the industry, we choose the message format and build a message modeling. So that also we can build here and use that to parse the incoming messages and validate the incoming messages. It's properly modeled, the proper message or not. So then we can include that message modeling in the our message flow to validate all those things. So once all this message flow workflow library is developed and in a way like whole application is get developed, then it's ready to be deployed into the runtime environment. So how to do that? In the runtime environment, we can package it in a bar file that's called a broker archive file. That is that contains, like you heard in other places, Java jar file and all that, war file like web archive file. So it's a broker archive file. So in that we have to package everything, application library, whatever it is, you have to package it, and that is becomes the our asset to deploy into the runtime environment. So that one we can deploy in the as a developer for easy for faster development and testing. You can drag and drop into the or deploy into the integration server directly. And in other cases like other higher environment, we can't do those things, so we have to follow the proper process. So for that, IIB gives the commands like IIB commands: mqsi deploy, mqsi bar file create, mqsi create bar file, mqsi apply override. So mqsi deploy commands, these commands it provides to deploy into the higher environment. Like we are doing it in the dev environment, later you want to move to the QA, SIT, pre-prod, prod environment. So these things we have to create it by the codes, that is commands. We can write our own commands. The command is given and we can write our own script to do that automatically when it happens. But nowadays we have some tools do these things like Jenkins, Bamboo, whatever tools we have. These are runtime continuous integration tools that will take care of handling these deployments. And before doing this, the tool, we have to provide a script, proper script to the tool. Once any application is built, and build also one script for that application to how to create bar file for that application, how to apply override properties and deploy. What is override properties? Here we have different environments like dev environment, QA, pre-prod. These are the environments we have. So when we want to deploy to the different environment, the value changes. Like web service call, here we have one web service call, that's endpoint is different, dev, QA is different, prod is different. And so this way we can't use the same bar file to deploy in each and every environment. So we need to create a separate bar file for each environment. For that reason, we have to create a properties file. In that properties file, we define the overriding properties where we can change the name. So in the then we have to create multiple properties file for each environment. Dev environment, dev properties, QA environment, QA, any name, plus properties is the extension of the file. So this way we have to create each for each environment. So once you create a bar file, it is a generic bar file now. So that bar file you have to apply these properties. So what happens, whatever the value needed for the particular environment, it get updated to the bar file. So if you use dev.properties to the bar file, it becomes a dev bar file. If you are pre-prod, if you apply that properties to the bar file, it becomes a pre-prod. So now we got each and every bar file for each environment. So whenever the dev is successful and QA is again QA test is running and it's passed, so again the same bar file is already created with the pre-prod properties. Though we'll ask the admin team to deploy to the integration servers. The particular integration server you have to deploy the same bar file that is particular to that one, because the coding is same as dev. Whatever the changes, if changes any QA, if you are doing any QA testing, some defect comes and assign it back and they are fixing again, then the dev and dev people, developers should create a bar to change the code and check in. So once it check in, the Bamboo will create a bar, so it will create for other environments also, QA, pre-prod and all, using a properties. So in this case, this process again QA deploys, then QA passes, then same bar file it deploys to, same means the particular to that pre-prod environment will get deployed. So it becomes a runtime environment. So then we can do the testing. This is the whole process how it works from IBM toolkit to develop it and deploy into the runtime environment. Okay. So now I'll see that how we can create applications, libraries, static libraries. This libraries, I'll just create two libraries. One is here, and there is a new. Right click onto this palette. There is a new. Then the library. So libraries. There are two options it gives. One is the shared library and the static library. Let me give the first shared library. So now I'll just name it as shared lib1 created. So it asks next, if you click, it will ask for any other libraries you want to reference. You can library can reference other libraries. So there is nothing like that. So I'll give a finish. So here in the library, I'll just we can include multiple things here: subflow, machine modeling, and SQL file mapping. So when I create a library, when we want to use that library for a common thing, so any common coding like ESQL file, we'll come through that later, and some message modeling like different kinds of message modeling, as I told, JSON, XML, all those things we can define here, and subflows. It's a common subflow. You'll just click the subflow and subflow one, and this is the subflow. And whenever you create a subflow, there is a two terminals will get created: output and input terminal. These are not executable things. It will not accept anything, but it can be a part of the main flow when you add it. So just these are just for a uh, testing purpose, I just add this compute node. This is the, we'll go through this later once done the, so how it works and all compute node. So now I'll double click onto this. So in this, there is a coding, default coding. So we'll go through that later. So just I'm telling now a shared library. So now this is the subflow it get created. Subflow is consider it as a common subflow, like anything, many banks, mini statement it want to create something, any sort of like that. So it will create a subflow here. It will do some operations. So you want to include this in the main flow, or exception handling it handles. So it will have to include the main flow to add exception handling, because exception handling used by multiple application, all the application. So we can include this in a common library, though it is a shared library now. So same thing, I'll create one static library. This is the static library, the second option, static lib one. Next, I'll not referring anything and finish. So same way I'll create subflow here. Subflow 2. So okay, these two shared library and static library. So how to use this? This is the common thing now. Library we created. So I'll create an application, A1 application. So here A1 is created. So I'll just refer anything here, library. Go to right click on to the application properties and project references. I'll select static library for this application. So it created, it refer now. When you refer static library, it comes under the included libraries. You can see the things here, and static library under this, it will referring now. So it included this library in this application. this application it included. So now I'll just refer the shared library. This is the this also there, and shared library also I'll refer. So it comes in the referenced library here, shared library. There is a difference here. It's included in the application. It's referred. So it is not created a separate copy for this application, but static library created a separate copy for the application. So whenever you want to deploy this, I try to deploy this in this A1. So you can drag and drop or right click and deploy and select the integration server, finish. So you can see the error popping up here. The application A1 cannot be deployed because it depends on the shared library. So which is not deployed in the integration server. So it expects the shared library already be in the integration server because it is a shared one. It's not a part of application. Unlike static library, it's not giving anything error for this included library now. So shared library, it wants it here before deploying. So let's deploy the shared library now. So you can drag and drop here like this. So shared library is deployed now. So I will deploy A1 here now. So now it's get deployed without any error. So it's finding that shared library which was asking for. So here you can see A1. A1 is referring to shared library. It's outside the application, but you can check static library is part of the application. So what happens here, whenever consider any business scenario, we want to change the common things here. Whatever present in shared library, you changed it and deployed a shared library again. Like you deployed now, you changed it, the shared library and deployed. So what happens? It's updated here. And also whoever referring this shared library, now A1 is referring, only one application is there. So it takes the latest changes in the shared library. No need to deploy again A1. So it takes care of this. But what happens if static library changes here? Static library changed. So again, it's included this copy static library. When you included here, copy of this one got included when earlier copy. The new copy, whatever you are making now, it'll update here in the workspace, but not here in this case because it is part of A1 and it's a earlier copy. Now new copy it has a changes, so we have to deploy it again A1. We can't deploy static like that. So here it's included, so again you have to deploy A1 if changes happens. So this is the difference. Based on your need, you can choose any one of these libraries. So mostly we'll use shared libraries, and this is also come in IIB 10 only. Earlier versions they have only static libraries present. So shared libraries, like it's useful when we have a common code like logging framework or exception handling. Some exception is thrown in the integration flow, message flow. So it will pass us back to the catch node, catch terminal. Then we can connect this subflow to that and handles the exception handling. It can host multiple things. I'll just create one more application. It can refer multiple things. A2. Next, you can give reference here only. Next means it asks for shared library list and the static library list at the bottom. So I'll use this shared library to add a shared lib one what I created and finish it. So now shared library created with the referenced libraries, that is shared library. So as I have shared library already in the integration server here, it's not part of A1, it's part of integration server. So in the same integration server, if I deploy, it will get deployed. A to deploy depends on the shared library. Share lib one. It's okay. It's went to actually wrong integration server common. So common we don't have. Just deploy it into the deploy. So it get deployed A2. A2 also referring this one shared library. A1 also. So it both are referring the shared library now. Anything changes in shared library, both get affected. Both will get the new copy of the shared library here. So if you change one more application, A3. So I'm referring static library now. So this is a static library, and I included the static library here. Static lib subflows. Here subflows are there. Static library 1 subflows and subflow 2. So now I'll deploy this. You can see the difference. So A3 having separate copy of shared library, static library, and this is having static library. Now we deployed it in some time back, and it has some separate copy static lib, and we changed the static lib and deployed it again for a A3. So what happens now? Changes, whatever the new changes only applies to the A3. It will not reflect here. So reflect the changes in A1 also. You have to deploy it again A1. So that is the difference between this static and shared libraries. Okay, so whenever you use this shared library, suppose you created one for application like this, some message flow I added mf1. How to refer that? Once you add a reference is there, once you add a reference to this application, that whatever the library is there, then only we can use that subflows under that. It's shared library is referenced. So I'll just create any flow, simple flow, mq input. I'm connecting just input passing to the output. Then here I just add here, right click here and add subflow, and it's part of our library now. Shared library we shared library, subflows, shared library, subflow one. Okay, so it will get added now to the main flow. So it's a common flow we are utilizing in the main flow, and just anything, it's consider it as exception handler. So any exception happens here, so it come back to the cache terminal. So it connected here, so it will processes and it gives back the result. So this way we can connect the subflows in the main flow. This is the main flow. You can see the difference here. The subflow is dot sub flow. It is a extension here, and for the main flow we have you have msg flow. This is the main flow. It is a runtime. Subflow will not run independently, but main flow is a runtime. It is a runnable flow. You can start the flow. It triggers the flow. Here it is a MQ protocol. There are different protocols available in the flow. So most major things are HTTP and MQ things. MQ protocols is a queue-based communication. If you use this kind of nodes available in WebSphere MQ palette, MQ input node, output node, reply, these things we can use. And if you are having HTTP nodes, these are the nodes available, HTTP nodes. And web services, we have a SOAP nodes. SOAP nodes, it's a SOAP based web service. Always use a SOAP envelope as a message in a message. Then there is a routing patterns, how to route it. Different ways of routing patterns are there. We can divert anything, route it to different destination based on the conditions or content of the message. And there is a transformation thing. There are different ways we can do it. Mostly we do compute node, and there is a Java compute node. It is built the Java compute node. In the Java compute node you have to write a Java classes, and different than the native Java class, the syntax will be different, but the concept, whatever Java does, it does the same thing. So next is XSLT transport. If you have to write a transform, we can write a XSL also in the transform. XSLT transform node you can use. And mapping node, it gives the flexibility to drag and drop that source to